everyone. So today we are going to be, what is this notification? Okay, so today we are going to be learning some basic laboratory orientation. And you'll be like, what is basic laboratory orientation? It's basically learning about things in the lab. And you'll probably be like, this is such a boring topic. But it's actually important to know. It's part of science. Because later on when you do experiments, you have to actually know this stuff. If you just enter the lab not knowing anything, you are going to be cooked. It's going to explode right in your face and you're going to be sent to the hospital. So you better make sure you learn this basic laboratory orientation. And not only that, we'll actually also learn some chemistry things like different apparatus, Bunsen burners, whatsoever, which is actually still important. Okay, but firstly, let's learn the basic stuff, okay? So now, of course, I can't go to the lab with you people, right? But I don't know if you guys have ever went to a lab before. Like, if you're in school, you probably have, like, a lab in school that, your teachers tell you guys to go to. If, like, I don't know, like, if you don't have it, or, like, you just never been to a lab, or you just, like, just stay at home and you just watching this video and, like, I have a lab. Okay, sure, but you can skip the basic laboratory orientation part, but you still need to learn about the Bunsen burners, whatever. Okay, but let's just learn it. Okay, so it's gonna be very important for your safety as well. Okay, so now let's learn some do's and don'ts in the lab first. Okay, this is like ground rules. Okay, although I'm not going to the lab with you, but just pretend like tomorrow you're gonna be going to the lab. Okay, or like you probably just click on this video because like you're gonna have to go for like some practical science test tomorrow whatsoever, and you got like, I don't know anything about the lab. Okay, then this is a good video for new people. Okay, now do's and don'ts. Okay, now firstly, if there's like a trusted adult or teacher or whoever accompanying you, but if you're some adult, then you basically just watch yourself. Okay, but if you are like a kid, then of course you need like some teacher whatsoever by your side. Okay, so always follow the instructions because they are the big brain people. They know what to do. Okay, now, you will probably, when you're in the lab, you have to record some measurements. You will probably have pieces of paper, or you have like a notebook or something, right? Okay, now, if you have that, I just remind you, it's made of paper, okay? And, okay, this is fire, okay? And if you're gonna put your paper, you're gonna throw in the fire, I'm pretty sure you guys will know what's gonna happen, right? Now, so keep all your papers, your notebooks away from whenever you're heating equipment or like any, flames whatsoever, because you don't want it to get burnt and then you cause this big fire and then you call the fire department over. Alright? Okay, now, if you are an adult yourself and there's no one gonna be supervising you, supervise yourself. If you are a kid, there's someone supervising you, of course there should be, then if you cut or burn yourself, you tell the teacher. If you're an adult, you probably should know what to do yourself, okay? But tell the teacher if you cut or burn yourself, because usually in these situations, it's pretty serious, alright? And if you break any glassware, spill any chemicals, alright, you need to clean it up. You need, I mean, you tell your teacher, okay? And then, after that, the thing needs to be cleaned up, okay? Now, do not do this yourself, alright? If there's this thing, okay, this is the thing. And it spills over. Don't just take a piece of tissue and just wiping it. No. You need to tell our teacher first and then see what the teacher can do. Okay, and if you break any glassware in the lab, okay, firstly, you shouldn't be breaking any of those. But if you do, also make sure you tell the teacher. Okay, now, when you're dealing with Bunsen burners, which we'll learn later, luminous and non-luminous flames, it's gonna be very hot, okay? Now, I've had experiences before where I touched, okay, actually I didn't touch a Bunsen burner. I've handled with a Bunsen burner before, and I'm just gonna tell you that I did not get burned whatsoever, but I'm gonna tell you that you don't want to get burned by it, okay? And I'll explain later why Bunsen burners are so dangerous compared to normal flames. You don't want to touch the Bunsen burner, especially the flame part. You don't want to be touching it, okay? I've handled Bunsen burners before. I'm actually being cautious because if I touch the Bunsen burner, my entire hand will rot. And I've heard people accidentally touching Bunsen burners, okay? It's gonna be very hot, okay? You better make sure you don't touch it, okay? Unless you're like some person who can like handle extreme temperatures, then you can try it. But I'm pretty sure you can't. Okay? So I've heard people, getting hurt by the Bunsen burners. But I've experimented with Bunsen burners. I've been in the lab before, so I know. Alright, now these are some random stuff, okay? If your lab has like some tables and chairs, there'll probably be. You better make sure you leave it clean and dry, okay, for the next person to use, okay? But this is some like some moral stuff, like, okay, it's not important. But you better make sure you do that. Don't just leave like some random stuff all over the tables. Right now, this is a very important thing. Okay. Now, if you're a girl, you're wearing like very long hair, right? Okay, maybe you don't, but like if you do, right? If you're Rapunzel, you need to tie it in. Because if you're gonna have this long hair and it like hits a Bunsen burner something, or your hair's gonna burn out and you are gonna too. So you better make sure you tie it up in a bowl, a bun, so that it won't just like stream all over the place and just hit a random Bunsen burner and you get burned up for no reason. Okay? Now, here's something very important. When you are burning chemicals, you probably have a test tube. This is super important. Test tube. Okay? And you're burning it. Now, what's gonna be happening is that the Bunsen burner is gonna be over here, right? It's gonna be burning. It's okay. And what is gonna be happening is that erase this first so that I can draw. The test tube is gonna be here. And what's gonna be happening is you're gonna be holding the test tube like this. Okay? Actually you shouldn't be because you may, if like it gets too hot, you even yourself, okay, but let's just say you're holding it here, okay, because definitely it needs something for support. Okay, so let's say you're just holding it or you're just doing like a pair of tongs, okay, because you can also use that to burn so that you don't burn yourself. Okay, but whatever, but there's gonna be something that's holding this test tube. Right now, where should you be pointing it? Think about it. Where should you be pointing it? Now, what most people will do, they'll try just do it like this. Okay, they'll be like, okay, I don't really care. They'll just like have test it over here, and they'll just like have it just pointing upwards to them. Wrong. If you do that, what's gonna happen? Okay, now it may not happen all the time, but sometimes when you're burning chemicals, they may just like bubble up and just boom, 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 and just explode a bit. That may happen. That's usually what happens. Okay, don't worry, you're not gonna get burnt. But if you point it right at your face, right upwards at your face, it may splash on you, and if you have hot seasonings, drips of chemicals, you better make sure that does not happen. Okay, if it does, then you better make sure you wash off any chemicals. But you better make sure that doesn't happen. So you point it elsewhere. Now, when I say you point it elsewhere, I do not mean point it at your teacher, point it at your friends. No, you point it at a place where there's actually no one, where it will just fly to the air. You don't want it to be pointing to someone else and hurt someone else, and then you get sued. Right? You better make sure that doesn't happen. Okay. Now, also, before any experiment, make sure you wear safety goggles. Now, I've been to the lab and I've not worn safety goggles. And you'll be like, oh, such a naughty boy. No. Because when I was in the lab, I didn't wear safety goggles was because the experiment that I was doing did not require safety goggles. Now, it really depends on the experiment you're doing. But if you're going to be doing anything related to chemistry, chemicals, that you have to take out some test tube whatsoever, burn some stuff, you better make sure you have your safety goggles on. If you are just like doing some random stuff like physics, like you are just measuring like, oh, how long is this thing? Oh, then you don't have to wear the safety goggles, okay? But if you are doing chemical stuff, chemistry stuff, you better make sure you wear all the safety goggles before and return it back to whatever the safety goggles place afterwards. And afterwards, you also have to make sure you dry the tables, which I said before, and wash your hands at the sink. Now, definitely be a sink at the laboratory. If there's no sink at the laboratory, that means your laboratory is out of budget. There must be a sink. You better wash your hands clean because if there's any like one drop of chemical, right, and you just eat it along with your food, then during like lunch whatsoever, you're gonna die. Okay, maybe it's not as serious, but it depends on what the chemical is. Okay. Now let's now go through some don'ts. Okay. Firstly, if you're like some rich guy, you have a laboratory at home. I'm pretty sure you don't. Okay, but you have a laboratory at home. Okay, let's just say you have a laboratory at school. You definitely have, right? If you're at school. You have a laboratory at school. Then, you better make sure that you enter the laboratory with your teacher's permission. Don't just enter it on your own straight, do it just to see, oh, this test tube looks very nice, I want to keep it. No. If it's at home, they also don't. Unless your parents are like, okay, you can enter. Or like your parents say, okay, or your parents like trust you a lot and you like know that you won't mess up. But if you mess up, you better make sure you know, okay? Better make sure you don't mess up. Okay, now, in the laboratory, don't run or push or misbehave, don't eat and drink, and you can use your sense of sight. You can use your sense of hearing, but never ever use your sense of smell. Now, actually, Sometimes you can use your sense of smell, but you better don't be smelling those toxic gases. You can smell the things that you're supposed to smell, but don't smell things that you're not supposed to be smelling, okay? Now, tasting, definitely no. Okay. Usually no. Now, when you need to smell substances, you better fan the odor to your hand. And what else is there? Okay, make sure you follow your teacher's instructions. Okay? About like disposal of substances whatsoever. And do not, most importantly, mix chemicals on your own. I'm sure you've all seen those kind of movies where like they take this chemical, mix it together, and the big explosion in the laboratory. Now, you may say, that's just exaggerating. No, you're not exaggerating. If you actually do the wrong things, it may explode. Then make sure you don't randomly mix chemicals. Okay, mix chemicals. Okay, if you're an adult and you're like a very well established scientist, you know what to do. You know that hey, this chemical gives me this. You're just testing things out. You know there won't be an explosion, then you can do it. But if you're some random student who doesn't know what this chemical is and you don't know what's gonna happen, you better make sure you don't do it. You make sure you just follow the teacher's instructions, because the teacher is the big brain dude who plans out everything and knows that okay, you're gonna take this and you're gonna see this beautiful thing. You're not gonna see an explosion. Okay? Now, if you have a flask, you have a test tube whatsoever, don't look directly at it. Because it will spit out something. Okay? Okay, so I think that's about everything for do's and don'ts in the laboratory. But now we're gonna learn about hazard symbols. Okay. Now the universal symbols, okay, by the GHS, okay, globally harmonized system of what's that, classification and labeling of chemicals. Now, when there's a chemical, sometimes you will see, right, this random symbol on it. This symbol isn't just a symbol randomly drawn by an art teacher in school. No, it's a symbol universally accepted. So this symbol you can always see in laboratories, like they mark it with chemicals. So they mark it on chemicals so that you know what are the consequences of certain chemicals. So firstly, we learn explosives. Now, you can Google up how the explosives look like, because my drawing is not that good. So I suggest you Google it up yourself so that you know exactly what explosives are. So just search explosives or hazard symbol. Okay. Now, explosive, the hazard symbol looks like this. It looks like this, this, and then you have like this exploding up. Okay. And over here, there's some random stuff over here. It looks like this is the explosive symbol, a hazard symbol. Now, explosive symbols means that a substance that reacts violently when heated or shock. So you better make sure you don't mess with it because it will explode. It's those kind of explosive stuff. Okay. So you examples like flash powder, okay, it will explode. So you better make sure you don't mess with it. Okay, if you see this, they usually have these hazard symbols on the chemical so that you guys will know, okay, hey, this is dangerous, right? You better watch out. That's why it's flammables. I'm pretty sure you guys know what flammables are. The symbol is pretty much just something like this, okay? Flame. Don't make sure oxidizer, because oxidizer looks something like this, okay? But later I'll explain what oxidizer is. Now, basically, I'm pretty sure you guys know what's a flammable. Something that can just fire easily, like alcohol, kerosene. Don't mess with it. Because if you put it near a fire, you boom, you will make a massive fire and tell the fire department over. Oxidizer looks like a fire, but it's actually not fire. It actually looks like this. Now, it's my drawing is actually very bad, but it looks just like this. Okay. Now, oxidizer means that it will decompose to release oxygen. It can cause or speed up a fire. Okay, so this kind of a basic knowledge lah. Okay, it's not like that important, but you need whenever you see this, you better at least make sure you know what it is. Hydrogen peroxide is an example. Okay. Now, gases under pressure is actually also a cool one. I'm pretty sure you guys know what that is. Basically, is where the gases are under pressure, they're compressed up at normal room temperature and pressure. Okay, so any puncturing or you drop, like they are usually placed in this cylinder. And if you drop the cylinder, you puncture the cylinder, you may cause an explosion because they're all under pressure. Right? It will just rock it out of control. Examples are like compressed carbon dioxide or helium, compressed helium. Yeah. Okay. Now, next one is corrosives. That's my favorite hazard symbol. I mean, I've never thought of me saying something like favorite hazard symbol, but that's my favorite hazard symbol is corrosives. Okay, because the name sounds cool, but actually it's stupid. Okay, the symbol looks very complicated. I don't know why. It's not that I like complicated things, okay, but just like, okay. Now, corrosive basically means that if you pour this substance on a surface of a substance, which is like, if it comes into contact with something, right, it will destroy and damage the surface of it. So, it includes like your table, and especially your hand. Don't pour corrosive on your hand thinking you have to drink it or whatsoever. No, it will destroy your entire hand. You will rot. Examples are sulfuric acid, I'm pretty sure this one you should know, and potassium hydroxide. Okay, now, actually also, that's physical, but now also learn that let's learn some health hazards in pictograms. Okay, now, the one that looks like a skull emoji, but the outdated skull emoji, which has this thing, that means acute toxicity, a substance that is harmful in small doses, like methanol, mercury, basically just harmful lah. Irritant is basically just like exclamation mark. Okay, it means it produces vapors of fumes, which in turn basically irritates the eyes, the nose, and throat, like ammonia, chloroform, I mean. Okay. Now, this is one, which is this random human. And then there's like a starfish on its chest, but it's like toxic stuff, like carcinogen, respiratory symptoms. It can be reproductive toxicity, target organ toxicity, mutagenicity, or aspiration toxicity. Yeah. Basically, if you swallow it, which you shouldn't even be swallowing it, it's gonna be fatal. It's gonna damage your organs, for example, like turpentine, petrol, lamp oil. Then make sure you don't mess with it. Okay. Now, environmental hazard pictograms. There's actually one that's important, which is basically this one. And just like there's a fish on the floor, right? There's some dirt over here. It's like a tree that's like no leaves on the tree. Basically, it's very toxic aquatic life, like pesticides, biocides, petrol, turpentine. Okay, so that is for the hazard symbols. Now let's learn about the different types of apparatus. Now I'm gonna draw this apparatus, and you'll be like, your drawing is so bad, right? No, but I'm gonna draw according to how it's supposed to be drawn. Anyway, what do you mean how it's supposed to be drawn? Now, every kind of apparatus in the laboratory has actually a way of drawing it, like an accurate way. That means you don't randomly draw it. Okay. Now, and we also learn about these sticks. Firstly, distal funnel. If you look at this, now it's basically just to transfer liquids into a flask. Okay. That's the usual kind, but it's also filter funnel, and for filtration. We'll learn more about it in separation techniques, insoluble solids, to separate things out. Okay, that's how it's supposed to be drawn. Okay, I'm drawing exactly how it's supposed to be drawn. Okay, now let's look at the top stand, which looks something like this. Now, it's basically to support your apparatus. So it's like this thing that will just like clinch onto it. Like you can just place it here, boom. It'll just help you hold it. Okay, it's like a free holding thing. Now it's a bell jar. Bell jar is for separating an experimental start from the outside environment. You have to enclose it. Okay? So you can put whatever things you need inside of the bell jar. There's a tripod stand as well. Tripod stand is just to support apparatus during heating whatsoever. You put the Bunsen burner, usually put it here, and you whatever things you need here on top. Okay? We're just gonna go through these. Beaker is the normal kind. I'm pretty sure you guys know what's a beaker. Now, actually, beaker, there's no way to measure it. So, if I ask you, tell me an apparatus that can measure things, don't have a beaker, because beaker is just to pour things inside, okay? Not to measure stuff. Flat bottom flask also not to measure stuff. It's basically like a flask, but okay, sorry, I didn't draw properly. There's actually supposed to be a flat bottom. Okay, so you can, uh, you know, it's upon on the ground. There's also round bottom flask, which is round on the bottom, not flat. Okay, and also conical flask, which looks something like this. Okay, they're all different types of flasks. Okay, but there's no like measuring things on it. What can be measured is measuring cylinder, which looks something like this. There are these markings, which you can actually tell, like if I pour liquid here or you know it's here. Okay, so if I, for example, if I tell you, okay, let's give a little quiz now. Okay. My liquid is over here. A lot of you will be why is this thing bending? Okay, because some liquids are like that. Now, so What's the answer? Now, either you tell me 22 because of this. Okay. About that, okay, 22. Or you tell me 22.5. Now, it's not 22.5, it's 22. Okay, because when you're measuring things in the measuring cylinder, you position your eye level at the meniscus, which is the lowest point, which is in this case is that. Okay, so that's for measuring, and usually it's an accuracy of 0.5 cubic centimeters. Next one is test tube, which I'm not even gonna draw. Fine, I'll draw it. Just like this. Okay, that's how easy it is. Okay, now there's a water trough, which is used for containing water when you're collecting gases. Okay. Now, evaporating dish, which basically looks like this, okay, is for evaporating, okay, evaporation to dryness whatsoever. Now, gas jar, which is something like this, is for collecting gases, okay. It's not confuse it with like whatever, like I don't know, magic cylinder, okay. And there's also a crucible, which is something like this, okay. It's for heating solids directly. So you just put your solid inside here, you put Bunsen burner heat, okay. Okay, so we are almost done, but lastly, let's learn something very important, one of the most important and my favorite thing in the laboratory called a Bunsen burner, which is gonna be burning your life off. Bunsen burner. It's used for heating. You don't use a random lighter, no, you use Bunsen burner. Okay, now, let's learn the anatomy of a Bunsen burner. I'm gonna draw it out for you guys, okay? Something like this, there will be this random thing over here, be this over here, like, something like this. Okay, I'm just trying to draw it out for you people. It's something like this. And there will. Okay, I'll explain everything. Okay, so firstly, the flame, I'm pretty sure you guys know, will be coming up here. Now, this is what we call the barrel to raise the flame to a suitable height for heating. Okay, this is pretty obvious. Now, just the air hole. Okay, now, usually to burn it up, there's gonna be air entering to the Bunsen burner. So it's to allow air to enter the burner, it will be entering from here. Okay, and this is the gas jet as well. The gas jet to allow the gas to enter the burner and mix with the air in the air hole. Okay, so firstly the air comes in, it will enter through the gas tap, which will later we'll learn, and then you will go through this gas jet, which will basically allow the air from the burner, okay, firstly can enter and mix with the air from the air hole. Mix. Okay. So gas jet is basically sorry, not the air that enters the burner, the gas that enters the burner to mix with the air in the air hole. So it's basically here's exactly what's going to happen. There'll be gases entering, and through the gas jet it will mix with the stuff in the air hole. Okay. Now, next one is this entire thing, which is basically called the collar. Now the collar is to control the amount of air that you know by opening or closing the air hole. So this air hole can actually be opened or closed. You can open it a bit, you can close it a bit. It's up to you how much you want to open or close it. So if you open it a lot of air will enter. If you close it, very little air will enter. It's up to you. Okay, usually you can touch the collar because usually it's the barrel that's hot. The collar will not be hot usually, unless there's a sharp back, which we'll learn later. Usually the collar will not be hot. So if the collar isn't hot, you can actually touch it, okay? But it's actually kind of scary because you'll be like, so you're so close to the flame, you'll be like, what if it accidentally becomes hot? But trust me, the collar won't be hot. Only the barrel is hot. The collar will never be hot unless there's a strike back, which we'll learn later. Okay, so when the collar is hot, when the collar is not hot, you can adjust anything. You can adjust the stuff in the air hole to control the amount of air entering and how much gas for the gas jet can be mixing with. And if you're wondering where the gas comes from, it comes from this thing called the gas tap. Okay? To control the flow of gas to the burner. Lastly, this is the most basic one. And no pun, okay, no pun intended, the most basic one is the base. Okay. Basically to serve on the burner so you know like you won't topple. Yeah? So you guys learn the definitions or at least learn what's everything's supposed to be doing. Now we're going to be learning two types of flames. Non-luminous, which I will just use the word NL to write it. and luminous. Now, non-luminous and luminous, there's a lot of differences. Okay, now, non-luminous. Now, remember how the air hole can be sort of controlled, right? Okay, now, non-luminous, just think of it this way. Non-luminous is the dangerous one. Luminous is the safe one, sort of safe, but it's actually not safe if you touch it. Okay, I consider this way. Non-luminous is the dangerous one, luminous is the safe one. Now, non-luminous flame is when the air hole is fully open. Remember how you can control it? The air hole can be fully open. If the air hole is fully open, agree that there'll be a lot of stuff going on, right? And of course, air hole is fully open, that means there'll be sufficient air entering the burner, which will be what? Mixing with the gas from the gas tap, and then after that goes into the gas jet. Okay? Now let's look at what's going on in luminous flames. Now, luminous flame is when the air hole is closed. That means there'll be insufficient air entering the burner to mix with the gas. So basically that's the difference. Okay, there's actually more differences which we'll go through later. Now, so first difference is, guys, listen. First difference: non-luminous flame, air hole is fully open. There'll be sufficient air entering the burner, which will mix with the gas. Luminous flame is air hole is closed. There'll be insufficient air entering the burner, mix with the gas. This is difference number one. Okay, difference number one. Done it. Okay. Now next type is, now in non-luminous is complete combustion. Consists of complete combustion. Okay, so there will be like in complete combustion, there will be a carbon particles deposited on the apparatus. Okay, this is number two. Number three, what is that? Now, this burns steadily. Yeah. Non-luminous flame, what is that? Non-luminous flame burns steadily. But luminous flames are flickering and unsteady. That is number three, whether they're steady or not. Later I'll draw a diagram. Right. Now, this is the most important part, which is hotter. It's of course the non-luminous flame. This one is more dangerous as well. The non-luminous flame is the hottest one because there's a lot of air, it's complete combustion. Alright. And now you'll probably be guessing, what's the color of the luminous flame? You'll probably say it's orange. And you'll probably think that the color of the luminous flame will also be orange. And if I say no, you'll probably say it's red or yellow whatsoever. But no, you're all wrong. It's actually blue. Yeah, non-luminous flames are actually blue. Okay. And not only is that, they are sort of invisible. But it's invisible. Okay, so I'm just gonna minimize this so that you guys can see everything. Make sure you guys remember, okay, everything. But this is what makes non-luminous flames so dangerous. Firstly, they're high temperature, and secondly, they're invisible to the human eye. Mostly invisible, which means that it's gonna be very hard to see. That means I could have a Bunsen burner over here, and it doesn't look like anything going out, but it's actually this secret invisible non-luminous flame out here, which is why you need to make sure that at all times your Bunsen burner is closed in the lab. Okay, if you're opening, you better make sure that you know it's open. Because if you just like leave it open there, you reach your hand over, like you want to grab something over here, you reach your hand over, you're gonna get burnt because you won't see the flame. If you can see the flame, you obviously won't touch it. But if you don't see the flame, that is the most dangerous part. Because sometimes you actually don't see the flame because it's invisible and you may actually touch it. So at all times, leave the flame closed. And if it's open, you better make sure you know it's open and you better make sure you don't mess anything up. Okay, now let's draw some diagrams today. Non-luminous flame and luminous flame, the diagram. Now, firstly, there will be a colorless zone of complete combustion outside. Okay, outside. Which I will just but with dotted line because it's colorless, right? There's no color to represent colorless in this case. Okay, now down here there will be a blue zone. Okay, and the tip of this blue zone is the hottest part. Because remember the blue part is the hottest, okay? And there'll be this a bit dark zone. This is unburned gas. Okay, and this is the blue part. Okay, this is how it should look like, but it's sort of invisible lah. Now, in the luminous flame, is the almost colorless zone, and then it's orange, guys. It's orange. That's interesting. Okay, now it's like sort of to the journey of being a non-luminous flame. So there will also sort of like a little blue on the sides. Okay, but mostly no. Okay, now this is also the unburned gas. Okay, and this is the orange zone. Orange zone of incomplete combustion. And I'm pretty sure you guys could have guessed this is the blue zone of complete combustion. This is also blue zone of complete combustion over here. That's about the burner. Non-luminous flame vs non-luminous flame vs non-luminous flame. Now, last and but not least. Okay, firstly I'm gonna show you how it will look like when heating up something in the beaker. Now, you probably think this, right? You'll be like, why is it levitating? Now there's actually a wire gauze over here. Just drawing some excess, okay, like a wire gauze. Tripod stand over here, the Bunsen burners over here is heating this thing up. Okay, so basically you have a tripod stand, step 1. Step 2, put wire gauze on it. Step 3, light the Bunsen burner, push it in. Step 4, just heat it up. Okay, and make sure you don't bother others people. Okay, now let's learn lastly. Okay, we are almost done. Let's learn something called strike back. Now, for many years I actually don't know whether strike back it's supposed to be one word like this, or is it supposed to be 2 words like this, or is it supposed to be hyphenated like this? Okay, but whatever the situation, I'm just gonna use it as one word strike back because it sounds cooler like one single word strike back together. Okay, but I've seen people use every version. Okay, let me know down in the comments below. Okay, so I'm just gonna write like this, doesn't really matter. Now, strike back occurs when there's too much air entering the air hole. So now, yeah, we know that if there's very little air, it'll be incomplete combustion. It won't be like that hot. There's insufficient air, yeah, it'll be cool. But what happens if there's too much air? It's like when you eat very little, you're gonna become super slim. You eat enough, that's good for you. If you're gonna eat a lot, you're gonna become super fat. Right? This is the fat kind. So you have the Bunsen burner. Okay. Now, it usually happens. Okay, first thing you need to know. Too much air entering the air. So this Bunsen burner, what the hell am I supposed to do at this point? So it's gonna become crazy. And instead of burning at the top of the barrel, it's gonna be burning at the jet because there's air over there as well. Right? It's usually just going to rise up slowly, but there's too much air just trapped over here. So it will also burn at the jet. And just so you know, the jet is where the collar is positioned. So the gas jet is over here. The collar is over here, just to remind you. Now, just like I said, the collar is safe to touch. It's not going to be hot. But when it's a strike back, the collar is going to be super hot and you can't touch it. If you touch it, you're going to die. Okay? I mean, you're not going to die, but you're going to burn. Okay? So, here's usually how you phrase the answer. What is a strike back? Firstly, it occurs when there's too much air entering the air hole. That's right, AH. And secondly, it will not, okay, it will, instead of burning at the top of barrel, it will burn at the jet, which is the collar. You can't touch the collar. Now, third thing, if they ask what you need to do if a strike occurs, they may ask this. If they ask what you must do when a strike occurs, tell them turn off the burner immediately. Now, just in case you guys are like how do you turn off a burner? I'll explain. Okay, but just make sure that when it's strike you turn off the burner because it's gonna be so hot. And just let it cool down a bit. Now, just like when I drew the Bunsen burner, it was cool and all. I drew something like this, right? Now, it's actually connected to this gas tap. Okay, and this gas tap is actually a switch that's actually like this thing lah. Okay. Okay. Now, you basically just need to spin or turn this thing. It's like a sink, you know. There are some kind of sinks where you turn and then the water will come out. Same thing, you are just gonna have to spin this around, turn it a bit, and then it will supply the gas in. So it's basically like a switch, okay? You turn it and then it will, and then the gas goes. It's like when you turn the sink, the water will come out. That's exactly what you do. Now, here's what I don't do. Let us strike back, right? Don't start to like fiddle and dabble with the air hose, trying to close it, open it, whatever, because you're gonna burn your hand. You're gonna burn your hand. Remember that the collar is hot, so don't touch anything here. You know what's not hot? This thing. So you better just do this. Just close it, boom. Let it cool. Let yourself cool as well, and then yeah. Okay, so that's basically the basic laboratory orientation. Thank you very much guys for watching. If you have any questions, you can drop them down in the comments below. I will definitely answer them. Okay, please consider giving me a like and subscribe because they will really help my channel out. And thank you very much guys for watching. Alright, and share this to anyone you know who wants to learn about chemistry or whatever. This is laboratory operation. Thank you very much. Goodbye. Peace.